Hello class 9th, welcome back to my channel. We have started with chapter number 13, surface areas and volumes from your NCERT textbook. We have discussed the first exercise in which we learned how to find out the surface area for a cuboid and a cube and how to apply the formulae to real life problems. The next exercise is based on the surface area of a cylinder. Before we learn what the formulae are or how to apply them to real life problems, let us see how the formulae have been established. To learn how the formula for surface area of a cylinder has been established, it's important to understand how a cylinder is formed. I'll try to demonstrate that, and probably you have already learned this in your previous class with the help of an activity. So I'm going to try to do the same here. So I have a sheet of paper here. I have a rectangular sheet of paper. For a rectangular sheet of paper, the longer dimension can be referred to as the length and the shorter dimension can be referred to as the breadth. Now what I can do is I can either roll this sheet of paper along the length, or I can roll it along the breadth to form a cylindrical shape. If I had to fold it along the length, this sheet would somewhat look like this. So this has been sheet rolled along the length. The length gets converted into this circular boundary. So this is what happens. Your length gets converted into this circular boundary. And the breadth of this sheet, when I roll this sheet along the length, what happened? The length got converted into this circular boundary, and the width got converted into this height of the cylinder, the vertical height. If I had rolled this sheet along the width, along this side, then this side would have become the circular end and the length would have become the height of the cylinder. So if I have to represent the concept with the help of a picture, it would be somewhat like this. So I have a rectangular sheet of paper. This is the length, the longer dimension, the shorter dimension is the breadth. So if I roll it along its length, it gets converted into a shape which resembles a cylinder. So the length gets converted into this circular boundary. So length is the circular boundary. I hope you are aware of the term used for the circular boundary. Circular boundary is known as the circumference. And this shorter dimension, the width, it becomes this height of the cylinder. If I had rolled it the other way, what would have happened? If I had rolled it along the shorter side, I'll draw the picture the other way around. Let's represent it like this so that it's easier to understand. So this is the shorter dimension and this is the longer dimension. If I had rolled it along its breadth, then the cylinder formed would be like this. Now the breadth has become this circular boundary. Which is the circumference for this circle, and the length represents the height of the cylinder. In this case, the breadth represented the height, and in this case, the length becomes the height. Just to understand how the formula was established, let us consider the first case where this sheet, the rectangular sheet with dimensions L and B rolled along its length, forms a cylinder like so. So what happened in that case? If we take case number 1, length becomes the circumference. Now circumference depends on the radius of the circle we are talking about. The breadth becomes the height. So let us say that the cylinder formed in first case. Let us say the cylinder formed in first case is a cylinder whose top and the base circles, which are identical, they have a radius r and the cylinder itself has a height h. So what will be the relation between the dimensions L and B of this rectangular sheet and the dimensions r and h for the cylinder so formed from this particular sheet of paper? Using this, we get L equals to, the formula for the circumference is 2 pi r, and the formula, and B becomes h. Going back, when we roll this sheet to form a cylinder, this sheet actually forms the curved surface of this cylinder. So sheet forms curved surface of cylinder. This means area of sheet is equal to the curved surface area of the cylinder. The area of the sheet, which is a rectangle, will be given by L multiplied by B. Now we have already obtained a relation between L and the radius, breadth and the height. So let us use these values over here. So L is 2 pi r, the circumference, into breadth is the height. So this is the formula for the curved surface area. I've used the acronym here, curved surface area of cylinder. Now this is the case where when I rolled the sheet to form a cylinder, I did not close its ends. The top is open, there is a circle open here, and the bottom circle, this is also open. In that case, the only surface in consideration would be the curved surface, and the area for that curved surface will be equal to the area of the rectangular sheet, which is given by the product of L and B. And with our observation, we have obtained that length becomes the circumference, which is 2 pi r, breadth becomes the height, which is represented by h. So the area of the sheet, which was to be calculated using the product of length and breadth, is now equal to 2 pi r into h. So the curved surface area of the cylinder is 2 pi r h. What if the cylinder was closed on both the ends? To close the cylinder on both the ends, I would be using a circular lid here and a circular lid here. In that case, I will need to calculate the total surface area of cylinder. The total surface area will be equal to, this means the area for all the surfaces, the curved surface, the top surface and the bottom surface. The curved surface area we have already calculated. To this, I need to add the top area and the base area, and these two are circles. The area of a circle depends on the radius, and the radius for these circles have been represented by r. So the area for top and the base circles would be pi r square. Same will be for the base, pi r square. The curved surface area is 2 pi r h. So the total surface area becomes 2 pi r h plus 2 pi r square. Now there are some common factors here. You could take them common. 2 pi and r. We will be left with h plus r in the brackets. So this is the formula which we will use to find out the total surface area of a cylinder. Depending on the question in hand, you will consider whether you need to find out just the curved surface, whether you need to find out the total surface, or you need to make some adjustment to the curved surface or some adjustment to the total surface area so that you can find out the required answer. Now, the formulae that we have established are meant for a right circular cylinder. In your book, you will see the reference to all cylinders as right circular cylinders. Now what does that mean? For that, let's take a look at the demonstration given in your textbook on page number 214. On page number 214, they have given you the demonstration and the meaning of the word right circular cylinder. So what they are trying to show here is that if you take a number of circular sheets of paper which would have no thickness, if you stack them up, then the stack would have some height and that stack would resemble a cylinder. Now when the stack is made in a way that this stack is perpendicular to the surface, to the ground, to the surface, the stack is perpendicular to the surface, then the cylinder will be called a right circular cylinder. The word right represents being perpendicular to the ground. Now there is another stack shown here. If the sheets were not stacked properly, they were stacked this way, in that case the shape formed is not a right circular cylinder. In your textbook, all the problems are based on right circular cylinder. So the representation for a right circular cylinder would be like this. The top and the base are two identical circles for which the radius is represented by r. The radius of the top circle and the base circle is same. The height is the perpendicular distance between the base and the top. So this is a perpendicular and this represents the height. So we have obtained the relations for right circular cylinder, the curved surface area and the total surface area are respectively given by these formulae. Curved surface area equals to 2 pi rh and the total surface area is given as 2 pi r into h plus r. Now let us proceed with the exercise. Exercise 13.2 on page number 216 of your textbook, 216 and 17. Let's take a look at the first question. The curved surface area of a right circular cylinder of height 14 centimeter is 88 centimeter square. So they're talking about the curved surface area for a right circular cylinder whose height is 14 and the area, the curved surface area is 88 centimeter square. Find the diameter of the base. To find the diameter of the base of cylinder, we first need to find out the radius of the base. Once we have the radius of the base, we will find out the diameter. Now let us see how we are going to solve this. Let us start with what's given to us. We've been given that the curved surface area is 88 centimeters square. The height, which is to be represented by h, is 14 centimeters, and we need to find out the diameter for the base. Now this is a standard representation for diameter of circle. We use the letter D. So what we know is the curved surface area of a cylinder is given by 2 pi r h. The value for this is 88. Use the value for h given here. The value of h is given as 14. Let's use it here in the relation. 2 into 22 by 7. Pi is given to be 22 by 7. It's given in the beginning of your exercise. Assume pi as 22 by 7 unless stated otherwise. So r is not given to us. Let it be as such. H is 14. On right hand side we have 88. Now we have an equation which is in r. We will be using this to find out the radius of the base of the cylinder. Let's simplify the left hand side. So I've got 88. All these numbers which are being multiplied here, let's transpose them to the other side. Solving, r comes out to be 1 centimeters. Now from here the diameter can be calculated, which is twice the radius. After this, I would like you to do question number 6th. Question number 6th, it's similar to this one. Let's take a look. Question number 6 says, curved surface area of a right circular cylinder is 4.4 meters square if the radius of the base of the cylinder is 0.7 meters. Find its height. Now what they did was, in question number 1, they gave us the curved surface area and the height. They asked us to find out the diameter. So what we did was, we used these two values to obtain the radius, and then we obtained the diameter. Now in question number 6, they have given us curved surface area and the radius, but the height is missing. So we will be working exactly in the same way. So in question number 6, we've been given curved surface area equals to 4.4 meters square. The radius of the base as 0.7 meters, and we need to find out the height. So let us work with the curved surface area. Curved surface area is 2 pi r h. Its value is 4.4. Using the values provided, I need r and h. R is given, h is missing. We will substitute r by its value and leave h as such. For this question as well, pi is to be used as 22 by 7. Radius is 0.7 into h equals to 4.4. Let's simplify the left hand side before I transpose the values. So 2 into 22 by 7. This can be written as a fraction into h equals to 44 by 10. This gets cancelled. H equals to 44 by 10. Transposing 2, 22 and 10 to right hand side. 10 was in the denominator, it will be in the numerator. 2 and 22 are in the numerator, they will now be in the denominator. So simplifying, this comes out to be 1 meters. So the height of the cylinder is 1 meters. Continuing further, let us take question number 2 now. Question number 2. It is required to make closed cylindrical tank of height 1 meter and base diameter 140 centimeters from a metal sheet. How many square meters of sheet are required for the same? Now looking at the question provides us with the dimensions. We've been given the height, we've been given the base diameter. In the formulae for a right circular cylinder, we need r and h. R is the radius, h is the height. So looking at the question, we have both. H is given. Diameter is given. From the diameter, I can find out the radius. So I have R and H both. Second thing, the units for the height and the diameter are different. So I'll have to convert. Either I'll need to convert both quantities into centimeters, or I'll have to convert both quantities into meters. For that, if I look at the statement further, I have been asked to find out how many square meters of the sheet are required for the same. Now here I get the indication. The answer should be in square meters. So the area of the sheet that I'm going to calculate should be in square meters, and for that the dimensions must be in meters. So I'll be working with both dimensions in meters. I'll be converting the radius into meters before I start with my calculations. Now, to find out the area of the sheet required, this is the final thing which I need to consider before I apply the formula. The area of the sheet required depends whether my cylinder is open or closed. Either it's open or it's closed, or maybe it's open at one end and closed at the other. These are three different cases, so we have to consider that. They are saying it's a closed cylindrical tank, so that means I will use the total surface area to find out the area of sheet required to make this tank. Let us solve. I am writing down the values directly. H is 1 meters. I need the value in meters. Then diameter is given as 140 centimeters. You can either convert it first, then find radius, or find radius, then convert. So I'm calculating the radius. Radius is diameter divided by 2. 140 divided by 2 is 70 centimeters. But I want the answer in square meters. For that, this should be in meters. Let's convert. To convert centimeters into meters, I need to divide by 100. So this becomes 0.7 meters. Since the tank is closed, you can note this for yourself. Closed tank. So area of the sheet needed will be given by the total surface area of cylinder, the formula for which is 2 pi r into h plus r. Let's use the values and simplify. So this is 2, the value of pi 22 by 7, radius 0.7, in the brackets height and radius added. Height is 1, radius is 0.7. Simplifying, converting the decimal number into a fraction. In the brackets I get 1.7, so this is 1.7. So I'll be writing this as either 1.7 or you can convert it into a fraction. So I'll just convert it into a fraction side by side. Simplifying. Now you must be tempted to cancel 2 and 10. But what I'm going to suggest is, whenever you have 10, 100, 1000 in the denominator, do not cancel them till you are sure that they will be completely cancelled and you will be left with factor 1 in their place. If you're going to convert 10 to either 2 or 5, it will not be beneficial. Why? Just because if you leave them as such, you can use them later on to introduce a decimal. Instead of getting answer in a fractions, what you can do, you can obtain a fraction with denominator 10, 100 or 1000, which is easier to convert into a decimal number. So that's what I'm going to do. I'll be multiplying my numerators. In the denominator I've got 100, and I'll be using this 100 to introduce the decimal back in the question. So obtain your answer, obtain the product. 44 multiplied with 17, it's 748 over 100. So this is 7.48 meter square. This is the answer for question number 2. After this, I want you to move on to 5th question. We are doing the questions in a random order. I'll be making you do the easier ones first, and then we will proceed to the harder ones. So let's do question number 5 now. Question number 5. A cylindrical pillar is 50 centimeters in diameter and 3.5 meters in height. Find the cost of painting the curved surface of the pillar at the rate of 12 rupees 50 paise per meter square. Now this is a very simple question. You probably have done questions like these last year as well. So there is a pillar whose diameter is given, whose height is given. Once again, the units don't match. You'll have to convert. And in which units you are going to work, you probably will get a clue in the question itself. Find the cost of painting the curved surface. So to find out the cost of painting the curved surface, first of all we will find out the curved surface area. Once we have the curved surface area, it will be multiplied with cost per unit. Now looking at the cost, it has been given for 1 meter square. So that means the answer for the curved surface area should be calculated in meter squares. So you have got the clue here. Convert your dimensions into meters and then work out the curved surface area, and finally find out the cost of painting. Let's write down our answer. So I am not making a statement. I'll be simply writing down the dimensions. The diameter of the base is 50 centimeters. The height given is 3.5 meters. I want the values in meters, so this is fine. I want to change this one. Let's convert. I'm calculating R first, which is to be used in the formula. So R will be 50 divided by 2, half of the diameter. So this will be 25 centimeters. Let's change it into meters. 25 will be divided by 100 and I'll get the answer in meters. So this will be 0.25 meters. If you want, you can simplify this and keep in fractions, or this could be 1/4 of a meter. So you could use either this value or this value. I'll be using this. It's in the simplified form. Now I need to first of all find out the area to be painted. The area to be painted is the curved surface area, which should be given by 2 pi r h. So this is 2 into the value of pi will be 22 by 7 because it's not indicated otherwise. The radius is 1 by 4 into the height is 3.5. So this will be the area to be painted. Now what you can do is you can either simplify here, or since in my problem, the question, I actually don't require to find out the area, I just need to find out the cost. I'm not simplifying here. I'll directly proceed to the cost of painting. The cost of painting 1 meter square is 12 rupees and 50 paise. So the cost of painting the curved surface area will be equal to cost per unit, means cost for 1 meter square, multiplied with the area to be painted. So I'm using this value directly here without simplification. Whatever simplification I have to do, I'll be doing it at this step. So 2 into 22 by 7 into 1 by 4 into 35 can be written as, 3.5 can be written as 35 by 10. Now simplify and obtain your answer. So 7 and 35 get cancelled. 2 and 10 get cancelled. 5 and 5 get cancelled. Let's write this as a fraction. This is 1250 over 100 into 22. I've got 4. All other values have been reduced to factor 1, which can be ignored. Simplifying, 0 gets cancelled. This can be cancelled. Now I don't see any choice here. If you want, you could cancel this, but I'm avoiding. So let us obtain the answer for this in the fractional form. 125 multiplied with 11. The numerator is 1375. In the denominator I have 20. So you can give the answer now in fractions. By division, this comes out to be 68.75 meter square. Sorry, it's not meter square, it's the cost, so the answer will be in rupees. It will not be meter square. Be careful with the units.